Okay, so here is the review on vectors and parametric equations. Yours is not in color in the packet, but this fresh printout is. So component form is end minus beginning. So if R is the beginning, S is the end. So we're going to do 8 minus negative 3 and negative 1 minus 9. End is Q, so negative 9 minus negative 10, and you can use your calculator. Negative 9 minus negative 10, negative 10 minus 5. Now we have an angle for this one. It says 60 degrees, and the vector has a length of 25. So if you're not sure, you can always change it into a right triangle. And the x component is always the magnitude cosine of the angle, and the y component is the magnitude sine of the angle. Have to make sure you're in degree mode. I am not. Okay, so we got 35 cosine 60, 35 sine 60. So here in number 4, we have the magnitude is 52, and the angle is 174. If you're not sure which comes first, cosine or sine, it is alphabetical order, like X, Y, C comes before S. So using my calculator, we get the components of negative 51.72 and 5.44. Draw a diagram, find the magnitude. Okay, 115 degrees is over here. Okay, well actually they give us the magnitude. So I'm going to find the horizontal and the vertical components. So this is 115 degrees. So we get 26 cosine of 115, 26 sine of 115. So that's negative 10.99. and 23.56. All right, now 230 degrees is here. The length of 15, so that's 15 cosine 230, 15 sine 230. So negative 9.64, negative 11.49. Find the magnitude and direction. So the magnitude is the square root of the x component squared plus the y component squared. That is 17. So then the direction, first I'm going to find this angle and then decide what quadrant it's in to then figure out the direction. So tangent inverse of 15 over 8 is 61.92. Nope, 93 degrees. And to the right 8 and up 15 puts the vector in the first quadrant, so 61.93 is the direction. Now for R, negative 8, negative 41 puts our vector in the third quadrant, so when we do the angle, we're going to have to do an extra step. So the magnitude is the square root of 8 squared plus 41 squared. So that's approximately 41.77. So then the angle is going to be the tangent inverse of 41 over 8. So that is 78.96 degrees, but that's this reference angle. So the standard position, we have to go add 180, so the direction is 180 plus 78.96 is 258.96 degrees. Find the component form, magnitude, and direction. All right, so end minus beginning. So -9 minus -3, that's like adding, so -6. So the magnitude is the square root of 12 squared plus 6 squared. Oops. 13.42. Because -12, -6 is in the third quadrant again, we have to use the reference angle that we find to get the direction. So 26.57 degrees is this reference angle. So I'm going to add 180 because we're in the third quadrant, so the direction is 206.57 degrees. All right, sketch a graph, find the magnitude and direction. So this is the component 5, -12. Kind of hard to see the axes here. So we're gonna go 5 to the right, 1, 2, 3, 4, 5. I'll count by twos, 2, 4, 6, 8, 10, 12. So the magnitude is 5 squared plus 12 squared. When we find the angle, that's going to be our reference angle. It's not going to be our answer because we're not in the first quadrant. It's this reference angle, so the standard position, I have to subtract that from 360. So the direction is 292.62 degrees. All right, first let me find the component form. -7 minus -9, -3 minus -1. All right, so we're gonna go 2, -2. So the magnitude, the square root of 2 squared plus 2 squared. 4 plus 4 is 8. If you want a decimal, you can do that. Square root of 8 is 2.83. The tangent inverse of 1 is 45 degrees. So the direction is 360 minus that, which is 315 degrees. Okay, dot product. We multiply the x coordinates and multiply the y coordinates. 63. So here, if I think of this, instead of in the I and j, -1 times -6, 5 times -2, -4. 8, well, let's just type it in. 8 times -7 plus 4 times -9, -92 for this one. 0 times 5 is 0, 9 times -8, so our answer is -72. Parallel, orthogonal means perpendicular or neither. So orthogonal means, or perpendicular is the dot product would equal 0. Parallel would mean they are a scalar of one, oops, I spelled that wrong, or a multiple of one another. And neither is neither of those. So let's try this one. I like to start with dot product. It's a faster calculation. 4 times negative 9 plus negative 9 times 4. That is not 0. So then, are they a scalar of one another? Could I take 4 and negative 9, multiply by the same thing, and get negative 9, 4? So let's see, 4, negative 9 is here. Negative 9, 4 is there. They're not going to be parallel. So this is neither. I like this form better. Negative 5 times negative 10 is 50, plus negative 2 times 25. Oh, that dot product is 0. So they are orthogonal. Perpendicular. Find the measure of the angle between. On your formula sheet, which I don't have with me, the angle is the cosine inverse of the dot product over the magnitudes. So first we have to find dot product, then we have to find magnitudes, then we have to divide them. So let's do the dot product. Negative 2 times 8 plus 2 times negative 1. So that's a dot product of negative 18. One magnitude is 2 squared plus 2 squared is square root of 8. The other one is 64 plus 1 is the square root of 65. So we're going to do cosine inverse of negative 18 over root 8, root 65. Let's see what that equals. Negative 18 divided by the square root of 8 times 65. Cosine inverse of that answer. We get 142.13 degrees. Okay. The dot product is going to be 9 plus that. Oh, that's negative 8. So 6 times negative 8, negative 48. Add them up. We get negative 39 for a dot product. That's going to be 9 plus 36 for a square root of 45 for 1, and 9 plus 64, and that is 73. Okay, so our angle is cosine inverse of negative 39 over the square root of 45 times 73. Negative 39 divided by the square root of 45 times 73. Cosine inverse of that answer is 132.88 degrees. So that's this angle in between. Switching modes to parametrics. Eliminate the parameter. I find it easiest to isolate t for the x equation and then substitute into the y equation. So I'm going to add 16. So x plus 16 equals t. I'm going to put that here. Let's distribute, and we get 1/4 x plus 4. This one, I'm going to add 4. And then divide by 7. So that's my t. X plus 4 over 7 plus 2. Well, that doesn't look very nice. I'm going to rewrite it as 1/7 x plus 4/7 plus 2, and then we can use our calculator. 18/7. So 1/7 x plus 18/7. So for these both are lines. All right, then here we're gonna divide by 3. So t is x over 3. There's our answer for 3. And then for 4, I'm gonna add 5 and then square root. So substituting into y. I forgot one thing before I hit n. When you square root both sides, you need plus or minus. So it's plus or minus 2 root x plus 5 plus 7 for the y. If you want to check, you could change your calculator mode to parametric. Go to y equals and type in the two equations. And notice the x button is now giving me a t because it says x, t, theta, n. So t is for parametric mode. For my window, I like a t min and max. I go -10 to 10. You could go bigger. And a t-step of 0.2 just to get a decent shape. And then when you hit graph, see I get this bottom piece and the top piece. So if you think about a square root, here's the square root function and the bottom is the negative square root function. So you need this plus or minus for both parts. All right, so for 5 and 6, write a parametric equation and vector equation that passes through these points. We need the initial point plus t times the component form. So the initial point is the 6, 3. -3 plus t, and then component form is 4 minus 6, -2 minus -3. So that's the vector equation. So then the parametric equation, we take the x components, so 6 plus -2t, oh, so I guess that could be minus, and then the y is -3 plus 1t. All right, let's do that again for 6. So the initial vector plus t component form, so 5 minus 0, -8 minus 6. So then the parametric equations are 0 plus 5t and 6 minus 14t. All right, word problems. Soccer ball is kicked with an initial velocity of 90 feet per second, 35 degrees at an initial height of 30. So we've got 90 cosine 35t, -16t squared, plus 90 sine 35t, plus the initial height of 30. Okay, so for your calculators, make sure you're in degree mode and parametric mode. I go to y equals, we got 90 cosine 35t, -16t squared, plus 90 sine 35t, plus 30. Now I'm gonna check my window. I can't have negative time, 10 seconds, we'll see if that's enough. I leave my t-step at 1. Can't go behind me, and this is moving pretty fast, so I'm gonna make that 100 feet away. And then I like to leave my y-min at -10 so it shifts my graph up a little bit. And then the y-max, I'm gonna go with 100, since we start at 30, and you picture the ball goes up and comes back down. So let's see if that graph is good enough. Whoa, okay. I'm looking high enough, but definitely not far enough to the right. So I'm just gonna make that 250. Better. Okay, maximum height, and then the height at 3 seconds. Well, the height at 3 seconds is easiest. I'm gonna go trace 3, enter. And the height is 40.87 feet. The maximum takes a little more work. I'm gonna hit trace, and I'm gonna go close to where the maximum is over here. Okay, and that's time 1.6. So then I'm gonna go to second window. I'm gonna make my table start 1.6 and my delta table 0.01, because then I'm looking every 100th of a second, and I do second graph is the table. I wanna look for the highest number over here. Looks like 3.8 at 1.61. So time 1.61 at a height of 71.638 feet. Okay, let's do it again for number 8. (30 cosine 30t) negative 16t squared plus 30 sine 30t plus 3 for initial height. Cosine 30t 16t squared this starts a lot lower, so I'm not going to go up to 100. I'm going to go to 20, and the velocity is much less than the problem before, so I don't know, let's go to 100 feet out and see if I can see the graph. Oh, I can definitely see that. I'm going to make it a little smaller. I'm gonna go to 50. Just gives me a nicer picture. Okay. Maximum height and the time that height is reached. So I'm gonna hit trace. All right, so it's near 0.5 for a t. So I'm gonna go to second window. I'm gonna change my table start to 0.5 with a delta table of 0.01. Do second graph. And I'm gonna look for the highest value close. I think that's here. Okay, so height is 6.5156 at time 0.47 seconds. And then when does it hit the ground? Oops. So I'm gonna close to when it hits the ground. So that's near 1.1 second. Oops, second window. So this is closer. So t equals 1.11 seconds. And the x distance away is 28.839 feet. Curious if I change this to 0.001. Can I get even closer to 0? Yeah, look at that. 1.107 and x is 28.761. Because this is closer to 0 than the other one before. Oops, oh, you can't see some of that. If you just do the 0.01, you don't have to do 001. If you just do 0.01, that should be fine. I was just curious. Forgot E was up here. So then find the height after 1 second. I'm gonna go trace. Oops, you can't even see it. Trace 1, and the height is 2 feet. Because at 1 second, we're at 2 feet. All right, then we're gonna start number 9. So the equations are going to be an initial velocity at this angle, and an initial height of 3.5 feet. Oops, you gotta make sure to put it in the right spot. Okay, so 110 is pretty far. If you think about the outfield of a baseball stadium, I'm gonna go to 500 feet. How high? I'll go 100 and see if that works. Okay, it worked. If your window did not, whatever you chose for your X and Y max, make sure to play around so you can see the whole graph. All right, find the maximum height. So I'm gonna hit trace and go near the maximum. Now that looks like it's near 2.3 time. So I'm gonna go second window, change my table start to 2.3 and leave delta table as 0.01. Second graph, and I'm gonna look for the highest value. It looks like it was right exactly at 2.3, and the height is 88.15 feet. Find the time at which it hits the ground and the distance. So we're going to trace again over here. Oops, sorry. All right, so near 4.6. So second table set, second window, 4.6. Second graph is the table. And I want when the closest to 0. Negative 0.19 is closer than 0.55. So it's 0.456 at 380.12 feet away. Is it possible for the baseball to be caught 5 seconds after it was hit? So if I trace to 5, the height is negative 28. So when t is 5, x is 408.72, and the y is way below the ground. And since it hits the ground at 465, so it's not possible to be caught at 5 seconds. Oops, not possible to be caught at 5 seconds. All right, another setup. 35 is the initial velocity at this angle. An initial height of 1.5. We have to graph it. Oops. I'm gonna make this 100 and see. Okay, way too high, way too far. I'll make them both 50. That's better. All right, maximum height. Trace, get close. It's around 0.7. Second window, 0.7. Table. Okay, the biggest number is here, so that it is at 0.7. How far is 18.768 with a height of 9.4083 feet. What time does it hit the ground? Oops. All right, trace again. So near 1.5 seconds. I think this is the closest. So at 1.47 seconds, it is 39.413 feet away. Find the height after 0.8 seconds. So I'm gonna go trace 0.8, enter. So the height is 9.26 feet, and the distance is 21.45 feet. All right, last problem. Initial velocity, cosine of the angle t, negative 16t squared, plus initial velocity sine of the angle t plus the initial height. Oh, it's baseball again, hang on. So I'm gonna go 500. All right. Trace, get close to the max. That is near 2.2 seconds. Here it is, so 2.21 seconds at a height of 80.625 feet. When does it hit the ground? Trace. Near 4.4 seconds. All right, this one is slightly closer than the negative, so 4.45 seconds at a distance of 314.66 feet. Is it possible to catch the baseball in 4.4 seconds? So I'm gonna do trace 4.4. Oh, and it's slightly above the ground. So I would say yes, it's possible. Because if the person's standing there, they could put their glove pretty low. Or at 3 feet, so around their waist, I guess. If so, what is the ground distance? It's 311.13 feet away. And that is the end of your test review.